construct a triangle of side length 6 centimeters, 7 centimeters, and 5 centimeters. So to do this, we need to first of all construct a base, and you usually tend to use the longest, but it doesn't really make any difference as long as you end up with the same triangle. So first of all, we'll put in that first side of 60 millimeters or 6 centimeters, and then we need to go and construct the 7 and 5 one. And we'll do this using the compasses. So we're going to put the point on 0, and we're going to stretch them out to make sure that they are at 7 centimeters. And from there, we're going to go up and draw an arc. So I'm going to draw an arc like that. So all of the points on this line here are exactly 7 centimeters away from this point here. So now I'm going to bring the compasses back down, and I'm going to go and set them to 5 centimeters apart. And then I'm going to go on to the other point, and I'm going to do exactly the same thing. And bring them round, and then draw an arc in. So all of the points on this line here are exactly 5 centimeters from this corner here. So now I need to just join these two up with a line. So from this corner straight through where those arcs join, and from the other corner straight through where these arcs join. And then I can measure this to check that this side here is exactly 7 centimeters and this side here should be exactly 5 centimeters long. Find the locus of all points equidistant from A and B. This is asking us to find what you call a perpendicular bisector. So we're going to draw in a line, we're going to construct a line that's going to go straight down there, and at all of its points it will be the same distance from A as it is from B. So to do this, grab our compasses, and we're going to set them to some distance apart that's over halfway between A and B. Has to be over halfway, otherwise they won't meet in a moment. And then all we're going to do is draw ourselves some arcs. So we'll put one arc in up here, and then we're going to move it down a little bit and draw in another arc down here. Once we've done that, keep your compasses exactly the same distance apart, and then transfer it to the other point at B. Then draw in the next arc, move it up a little bit, and then join up to the other arc. Once we've done that, we're free just to draw the line going straight between these points, and that will be the perpendicular bisector. So all of the points on this line, we are exactly equidistant from A and from B, and obviously I can extend that line infinitely in either direction. Find the locus of all points equidistant from AC and AB. Now this is what you call an angle bisector. So I'm going to construct a line in a moment. It's going to go through here, and at all of its points it's going to be exactly the same distance from AC as it is from AB. To do this, take the compasses, and we need to get them onto this side here. Now this can be at any distance at all. It doesn't have to be over halfway or anything like that. So we just need to make a little mark, a little arc on here, move them around, little arc on the other side. Once we've done that, we're going to go to that new point that we've just made, and we're going to make an arc like that. Same thing from the other side, so we go to this new point that's just been made, and we're going to join up that arc with the other one I've just got. So now we've got that nice little construction there. We've got these arcs that have joined together. So from the angle, I'm just going to go straight through where the arcs meet, and that you should be able to see has perfectly bisected that angle and cut it exactly in half. So all the points on here, this is at the same distance from AC as it is from AB. Find the locus of all points 3 centimeters from AB. Now you should be able to see that this is going to give you a roughly oval shape. So to complete this construction, first of all we need to put 2 circles on the end, and we're going to need them to be 3 centimeters apart. So before I do anything else, I should really take the compasses down to the ruler and measure out 3 centimeters. Once we've done that, take them over to A, and we can draw ourselves a circle at A, and then do the same thing at B. Now, I think it is enough here just to join up the top of this circle with the top of the other one. But if you wanted to, just to be certain, you could go and create another circle, just to make absolutely certain that you put it in the right place. So now all I need to do is join these up, tops up with a line. So line going straight across, like so. And again from the bottom, line going straight across like that. So all around the outside of this oval is exactly 3 centimeters from the line AB. Okay, a couple of slightly different types of questions. Shade the area that is more than 4 centimeters from A, nearer to CD than CB. So more than 4 centimeters from A. Well, let's get the compasses out and measure out 4 centimeters. Take them over to A, and I can draw a circle there. So anything that's not inside that must be more than 4 centimeters from A. Nearer to CD than CB. So CD up here, CB along there. So if I want to find the points that are nearer to CD than CB, I first of all need to construct a line that is exactly equidistant between them. So I'm looking for a line that's going to come in through here, and it's just the angle bisector of these two sides. So I'm going to do the angle bisector. So remember, put the point on the angle, can be at any distance at all. Just make a little mark. Same on the other side. Take the compasses to those new points, and we're just going to make 2 arcs that will join up with each other here. There's one. Put that back because that wasn't meant to happen. And here's the other. So now I'm just going to draw a line that goes straight through those 2 points. Like so. Okay, so now we just need to shade the appropriate area. Nearer to CD than CB, well, that will be anything that's on this side, because nearer to CD than CB. But obviously we can't also use this area because it has to be more than 4 centimeters from A. So the area we're interested in really is this one in and around here. Okay, final example. Indicate clearly the points that are exactly 6 centimeters from A and equidistant from BC and BA. So let's do the exactly 6 centimeters from A bit first. That's the easy bit. So 6 centimeters from point A. So we will draw the circle in from that. And then equidistant from BC and BA. So this is between this line and this line here. So I'm going to need an angle bisector running through kind of like here. So let's go and do the angle bisector, which you should be familiar with by now. So stick them at any point on the outside and make an arc. So let's do one here and move down to this side and do one down here too. Once we've done that, we can take the compasses to the newly constructed point and make arcs at the top. So we'll have one there, and we'll have one from the other new point there. Now we just need to join these 2 points up, so from B, going through where the arcs meet, like so. So all that's left to do now is indicate clearly the points that are exactly 6 centimeters from A. So that's anything that lies on this circle, and exactly equidistant from BC and VA, which is anything that lies on the red line. So the 2 points that satisfy both of those criteria are here and also here.